In this video, we are going to use the cross product to find the area of a parallelogram to begin with, which we'll be able to find the area of a triangle. Now, recall that area of a parallelogram is a base times a height, but the thing is, my height isn't the side of the parallelogram unless it is a rectangle. So we need to actually find a height to find this. So I use two vectors because I would like to relate this to vectors somehow, and we're going to work from here to try to come up with the area of this parallelogram, which means I need to find this height here. I need the right angle height. We'll call it h. Let's also call this angle theta because we're going to use theta to find that h, right? So we can actually use trig here to come up with a formula to help us. Okay, so if I take sine of theta is equal to h over, remember the length of v is not v, it's the magnitude of v. I could solve for h here. H is v magnitude times sine theta, right? So we can use that to help with the area. Okay, so here's our area. And I'm going to put a P here for a parallelogram because we're going to do triangle here in a moment. Area parallelogram, I need the base. Okay, the base is the magnitude of u times the height, which is the magnitude of v times sine theta. And we know from the last video, this is the same thing as the magnitude of u cross v. So that's kind of nice. The area of a parallelogram is literally just the magnitude of the cross product. Now, I can create a triangle out of this, given the two sides. And the area of a triangle, I'll draw a triangle there, is just half that. 1/2 times the magnitude of u cross v. It's a little neat formula there. Okay, let's do an example of this. They want us to find the area of a triangle PQR. So I just need, if I look at my vectors above, I need two vectors that start from the same point. So I'm going to need to come up with PQ and PR. I need them to be from the same point. We know how to do this. We just subtract terminal minus initial. -2 minus -4 is 2. 3 minus -1 is 4. 2 minus 2 is 0. Okay, and then we'll do the same thing for PR. -2 minus -4 is 2. 3 minus -1 is 4. And then -1 minus 2 is -3. Right, so if I want the area of a triangle created by that, so we'll do triangle PQR, that is 1/2 times the cross product of PQ with PR. So we got 1/2, and then we're going to put this big algorithm in here. This is IJ, okay? And then we put the numbers 2, 4, 0, 2, 4, -3. There's my determinant, and then we'll put brackets on the outside of that. Okay, so we get 1/2. Put a big bracket, and then I'm going to write this in here. Okay, we got 4, 4, 0, -3, I minus 2, 2, 0, -3, J plus 2, 2, 4, 4, K. All right, that is 1/2 times -12 minus 0, I, minus 1/2, -6 minus 0, J, and then plus, and this is just going to be 0K. Check that out. Okay, that's going to be equal to the halves there. Okay, I got -12, I got -6I, and then that's going to be -6, so it's going to be a 3J. Okay, but that's not what we wanted. We wanted the magnitude. We actually probably should have done this the whole time. Big. Okay, so there we go. Just to be correct, those are my magnitude bars. Take my magnitude now. I got 6 squared is 36 plus 9, which is the square root of 45, which is a great answer. All right, so the area of that triangle is the square root of 45. Don't forget the magnitude. The good thing is what leads you to know that the magnitude is I'm finding an area. When I got done, I was like, I have a vector. That doesn't make sense. I'm trying to find the area, which reminded us that we need to take our magnitude. Okay, here's our geometric properties of the cross product before we jump into some applications. The first thing is that U cross V, I think this is the most important thing. U cross V is orthogonal to both U and V. We're going to use that quite a bit. We also have the formula number 2. We just use that to find area. U cross V equals 0 if and only U and V are scalar multiples. This also means parallel, right? That is the definition of parallel. And then U cross V is the area of a parallelogram, which we can use for a triangle as well.